Welcome to finding an algebraic equation given the graph. So you will, if you could kind of like ignore some of this stuff, it's there from the app I was using, but we'll make it through this. Okay, so what we have so far is we have midline, amplitude, and period. And the midline is pretty easy to see right here. It appears that our midline is equal to 10. We can also think about our midline as our max plus min over 2. Well, let's see. If we look at our max, we have a max value here and a mid value here. So we're at 16.75 plus 3.25 over 2. Yeah, that yields 10. So there's a few different ways to get at all of these things. Amplitude. We can either see that amplitude is the distance from the midline to a minimum or from the midline to a maximum. So doing that, we can really clearly see that our amplitude is 6.75. But we could also use our max minus min over 2, and our max is 16.75 minus 3.25 over 2. We're at 16.5 over 2, which is in fact 6.75. So you can either visually check it out sometimes, or if you need a this thing. So our period, we know, is the time it takes to do one wave. So what we know is that from what we talked about is that our I'm struggling with what we knew before. 2 pi divided by b equals our period. That's what we knew. But we also can rearrange this equation by dividing by period and multiplying by b, and we get 2 pi divided by period equals b. So these two nice little equations will always be able to yield either our period or our b. So in here we can see that, let's see, if we look at a wave that starts here. There's one wave. Well, we can tell that that x distance from negative 27 to 9 is going to be a distance of 18. So our period is 18, and that makes b, in this case, 2 pi divided by 18. We're always going to reduce. Our b is pi over 9. So we're almost all the way there. All we have to decide is what kind of a function is this that starts on the midline and increases in that way. Well, we know what that is. Signs on the line. We're going to use a positive sine curve. We have all the information we need. We're ready to build our function. Let's call this function f of theta. And our function then is going to be our midline, 10, plus, because it's a positive sine curve, 6.75. We're going to use a sine curve, and our b is pi over 9. So pi over 9 theta. There we go. Let's try another one. So we'll go a little faster through this one. We can see for this one, oh, that's so nice. Our midline is 0. And we can tell that our amplitude from 0, that one's, oh, these are really hard to see. Sorry about that. This is the point negative 18, 0. This is the point negative 16, 2.25. And then this is the point 14, negative 14, 0. So we can tell from there that our amplitude is 2.25. We can also see that to go through one wave would be like there we've gone through a trough and we're back to the beginning again. That x distance from negative 22, 0 to negative 14, 0 is a distance of 8. So it looks like our period is 8. Let's just kind of check that out. So if that's negative 14, then we go back here, and that's going to be at 8 less than that. So that's going to be at 6. And then we go another 8. And that should be at positive 2. Oh, and that makes sense. So if our period is 8, and we know that b then is equal to 2 pi divided by 8, or pi over 4, always reduce, that makes sense that if this is a distance of, if this takes us back to 6, to go half a period will take us back to 2, and halfway between this will be a max. We're sitting right there on the x-axis at a max, and we know what kind of function that is that starts at its max and goes through. We know that that is our cosine function. So we're ready to build our function. We'll call this one g of theta. So g of theta is equal to our midline, which is 0. It's a positive cosine, so amplitude times cosine. B is pi over 4 theta. Let's try another one. Here we've got a nice little function. Oh, I'm going to do this right away. We're starting on the line. So I know starting on the line, I'm going to make this a sine function. But I can also see that it's a negative first. It's a decreasing sine function. So right off the bat, I'm going to take a note. I'm going to make this a negative sine function. Now we can get into the arithmetic. Let's see. It is clear that my midline is at negative 4. And to go from negative 4 up to negative 1.25, or to go from negative 4 down to negative 6.75, my amplitude is 2.75. Keep in mind, amplitude is always a positive number because we're talking about a distance. We've got our midline, we've got it's a sine, we've got our amplitude. All we need left is the period. And we can see to go through one complete cycle, there we go, we'd start repeating ourselves. We go from an x length of 0, it takes us all the way out to an x of 19. So it looks like our period is equal to 19. That means b is equal to 2 pi divided by 19. Oh, we can't reduce that. We can just leave that. We're ready to build our function. How about h? H of theta equals midline negative 4, and it's a negative sign, so negative 2.75. Oops, excuse me. I'm trying to go fast. Negative 2.75 sine of 2 pi over 19 theta. Let's try another one. If you're good to go, you can log off and start your homework, but I'm just trying to give you enough examples that you can slow them down and go through them and work them at your own pace. If we try another one, we're looking at this. Oh, there's our minimum value right there. I'm going to grab that first again. I know that this is going to be a cosine function because it starts at a min or a max, but being it starts at a min, this is definitely going to be a negative cosine function. Let's see, here's my midline right through there. So I could either say max minus min divided by 2, but I can see my midline is sitting right here at y equals 2. My amplitude is distance from my midline up or distance from my midline down, and we can see that our amplitude is 1.5. We look at our period to go through one cycle. There we go, that's one cycle. We're going from an x value of 18 and an x value of -6. So notice I should have perhaps pointed these out. These are both about the y values because there are vertical stretches and compression. And the only thing we have about x values so far, before we add one more on Thursday, is period. So we can see that our period is 18 minus -6. So we're at 24. And that means B is equal to 2 pi divided by 24. Always reduce. We're at pi over 12. We're ready to write it. How about K? K of theta is equal to our midline. It's a negative cosine function because he's at a min value, so minus 1.5 cosine pi over 12 theta. One more example. Here we go. Looks like it starts on the midline. Let's check it out though. Let's grab everything else first. If our midline goes right through here, our midline must be at 7. And to go down or up from our midline, we're going either up to 14.75 or down to -0.75. Our amplitude is equal to 7.75. Period. Let's see how long it takes to get through one cycle. There we go. We'd start repeating ourselves. So we can see now the x values between -6 and -12 is 6. And so that means our B value is 2 pi divided by 6 pi over 3. If that's a distance of 6, let's just make sure that we're hitting at the midline. Oh yeah, that's the midline. It looked like the midline, but you want to just make sure. So if we're on the line, that means we're going to use a sine function. But it's decreasing first, so we're going to use a negative sine function. We're ready to write. How about m of theta? M of theta is 7. Minus, it's a negative sine function, 7.75 sine of pi over 3 theta. Finding the algebra.